omega is along minus k cap. And the third consideration will be if magnitude of omega increases, then alpha is along minus k cap, and if its magnitude decreases, alpha is along plus k cap. Now coming to the seventh point, which is about the relation between linear and angular parameters. So the first relation we have is linear velocity is angular velocity cross r. So this is cross product of omega and r. Here v is the velocity, omega is the angular velocity, and r is the radius vector. So if we found the magnitude of velocity, that is magnitude of omega cross r, so that will be omega r sin 90, which will be omega r is equals to v. So this gives us the result between linear speed, angular speed, and radius. Now coming back to acceleration, so we know that acceleration is dv by dt, that is differentiation of velocity with respect to time. This can be written as d by dt, substituting v as omega cross r. Now applying cross the uv rule in this differentiation, we have d omega by dt cross r plus omega cross dr by dt. Now this d omega by dt is the acceleration alpha, angular acceleration alpha. So a can be written as alpha cross r plus omega. Now this dr by dt is the velocity, omega cross v. So we have acceleration as alpha cross r plus omega cross v. Now here is the thing. Alpha cross r is called the tangential acceleration, and if calculated, its direction will be along the line of action of velocity. It may be parallel to velocity or may be anti-parallel to velocity. Now there is a point. If tangential acceleration is along velocity, it is parallel to the velocity, speed or magnitude of velocity will increase. Whereas if it is opposite to the velocity, that means speed or magnitude of velocity will decrease. So this is analysis what we can make about the tangential acceleration. So tangential acceleration is alpha cross r, r is the radius vector over here. Now there is another thing which we call as the centripetal or the normal acceleration. So centripetal or normal acceleration is given by omega cross v, and if calculated, its direction is perpendicular to the velocity. Now there is another point of discussion that magnitude of this tangential acceleration is alpha cross r, which is alpha r sin 90, because alpha and radius vector are mutually perpendicular. So magnitude of tangential acceleration is alpha r, or we can say that it is equal to alpha into r. If observed graphically, we can say that graph between AT and alpha will be a straight line and tan theta will be r. So if we have three different cases, three different graphs, then we can see that corresponding to third graph, theta 3 is greater than theta 2 greater than theta 1.